For the past 2 centuries, human industrialization has treated the planet like a limitless quarry. We have stripped the topsoil, pushed oceanic fisheries to the point of collapse, and pumped billions of tons of heat-trapping gases into the atmosphere. The traditional response to this ecological crisis has been an ideology known as bioconservatism. This is the belief that human technology is inherently destructive, and the ethical path forward is to halt progress, reduce our footprint, and retreat from nature. But stepping back now does not heal the damage. When you remove human influence from a severely degraded ecosystem, it does not return to a pristine state. It collapses. Passive conservation simply abandons the biosphere to decay on its own. Earth is effectively a closed system for matter. Within any closed system, concentrated energy naturally spreads out into chaotic, unusable states. We call this entropy. Human industry acted as a hyper-accelerator, burning concentrated chemical energy and scattering it as waste heat. In 1865, the German physicist Rudolf Clausius codified the second law of thermodynamics, proving that the entropy of the universe always tends toward a maximum. Energy inevitably spreads out. Earth only survives this universal decay because it receives a continuous, steady stream of highly concentrated, low-entropy energy from the sun. Plants capture it, animals consume the plants, and the biosphere maintains its structure. Traditional environmentalism rejects massive technological intervention, arguing that we should let natural systems manage themselves. But this misses the mathematical reality of our current thermodynamic state. Reversing the sheer amount of planetary decay we have caused requires massive artificial structural organization. You cannot reconcentrate scattered energy or rebuild shattered food webs by doing nothing. Reversing planetary decay requires the same active structural management we apply to a power grid or a satellite network. It is a problem of thermodynamic engineering that requires deliberate control. This realization has birthed a radical new political and environmental stance, Technogaianism. It argues that instead of fearing emerging technologies, we must actively research, develop, and deploy them to restore the Earth. Standard transhumanism focuses on using technology to enhance the individual human body and mind. Technogaianism takes that same philosophy and applies it to the entire planetary ecosystem. Executing a repair job on a global scale requires a level of intelligence humanity cannot provide on its own. It requires democratized, agentic AI, artificial intelligence systems that can act independently to monitor millions of interconnected biomes simultaneously. These AI networks ingest data from satellites, ocean buoys, and soil sensors. They track shifting weather patterns, predict ecological tipping points, and actively direct automated machinery to manage environmental variables in real time. Because atmospheric shifts in one hemisphere are directly tied to oceanic cooling in another, these AI systems must track variables that move across national borders. Effective intervention requires a single, unified chain of command that operates above the level of the nation-state. This aligns closely with the vision outlined by World Economic Forum founder Klaus Schwab, a fourth industrial revolution where the physical, digital, and biological domains merge into one interconnected management structure. If we accept the responsibility of monitoring every biome on Earth, our role changes. We become active participants in the planet's health, diagnosing and treating ecological failures with the same precision we apply to human medicine. Nature has been wounded too deeply to survive on its own. It requires a technologically driven artificial immune system to maintain equilibrium. We are already building the tools for this immune system. At the microscopic scale, molecular nanotechnology is being developed to sift through toxic landfills, breaking down garbage atom by atom and converting it back into raw materials. Through synthetic bioengineering, scientists are designing bespoke microbes from scratch. These living, lab-grown machines are deployed into oil spills and radioactive zones, specifically to devour hazardous waste. In agriculture, we are mapping and altering plant DNA to create genetically modified crops that can thrive in severely degraded, high-temperature environments where natural strains wither. Engineering biology down to the molecular level creates profound ethical friction. As historian Yuval Noah Harari notes, when you can read and rewrite genetic code at will, biological life effectively becomes hackable. When a forest is managed by sensors and populated with engineered DNA, the distinction between natural and artificial becomes a matter of semantics. Both are parts of the same engineered system. Before we can fully re-engineer the open systems of the Earth, we have to prove we can manage enclosed ones. We have to build artificial, closed-loop ecological systems. We have tested this concept before. Facilities like the Biosphere 2 complex were designed to isolate humans, plants, and animals under massive glass domes, allowing scientists to manipulate a completely sealed ecology without risking Earth's primary systems. These highly controlled environments prove that precise human intervention, guided by sensors and mechanical engineering, can successfully sustain a balanced, isolated ecosystem indefinitely. Solving the equations of a self-sustaining biosphere provides the blueprints for survival beyond Earth. The technology used to keep a dying planet breathable allows us to build cities on airless worlds. This brings us to the ultimate, macro-scale goal of transhumanist environmentalism, the deliberate terraforming of Mars. To turn a dead, irradiated rock into a fully habitable world requires a staggering display of atmospheric geoengineering. It means deliberately triggering greenhouse effects to raise temperatures, melting polar ice, and seeding a synthetic biosphere to generate oxygen. We are moving toward a future where saving nature requires us to artificially engineer every aspect of it. And when we finally finish rewriting the code of the Earth and the planets beyond it, we will have to decide whether we have proven ourselves to be the caretakers of the cosmos or its absolute controllers.